will proceed in primitive calculus, and we are calculating derivative of sine wave not through first principle. So that is the concept, so that we will proceed on. Calculation of derivative of sine wave not through first principle. So that is the idea that we want to proceed upon. So can we calculate derivative of sine wave without sin x without first principle? So what we have seen till now, that calculus integration is nothing but calculation of the area. Through that we do the addition, and doing the addition through area is nothing but integral calculus. So when we calculate area and width and height, if both are constant, then it leads into rectangle, and area is width into height. So it is also a multiplication, and through multiplication we calculate the area, but the end is focus is on area. Calculation, when we calculate the addition through multiplication and through area, focus is on area. If focus is on area, then it becomes kind of first numerical science transform into algebra, then algebra transforms into calculus. So this is what we have seen. So if I am calculating area of a rectangle, then width is, if we consider width as x-axis and height as y-axis, then y is function of x. So height is function of x, fx. If height is fx and width is x, then area is fx into x. But height may not be constant all the while. If it is variable, then area cannot be height into x directly. So now we can, it's an abstraction now. Fx into x is the area, or fx is the rate of collection, then fx into x is the net collection. So calculating from rate of collection to net collection is integral calculus, is the area. Algebraic area. Numeric multiplication is modified to algebraic multiplication, or then calculus area. So fx height into width is numeric multiplication. Fx into x is algebraic multiplication. Fx into dx from limit, this is area algebraic. Area through algebra becomes integral calculus. Height into width, that is a rectangle, it is multiplication. Then fx into x is algebraic multiplication. Fx into dx is calculus integration. Same thing. This here also area of rectangle, here also area of a shape, and then here only area, not through multiplication. So it is also not called fx into dx. People generally call fx dx because the focus is on calculation of the area that fx forms along x-axis. Fx dx from one point to another point, from lower limit to higher limit. Now idea is that if that is the case, what is integral of x to the power 5, x to the power 6 by 6? What is integral? If integral of x to the power is x to the power 6 by 6, people, they remember it, they mug up. Okay, then what is integral? I don't know what is integral, but I know integration of x to the power 5 is x to the power 6 by 6. X to the power 5 is fx. It's an algebraic graph where x-axis is there and fx is the algebraic graph, a line, curve. If you get the area from one limit to other limit, left hand side to right hand side, that area is nothing but integration of x to the power 5. So if you calculate the area, then it becomes x to the power 6 by 6. If this is a triangle, then area triangle, then equation is x. Then integration of x is x square by 2. That is nothing but area of a triangle is x square by 2. So integration of any polynomial equation is nothing but area. It covers. That's it. So integration of x to the power n is x to the power n plus 1 divided by n plus 1. Similarly, differentiation, that is other way, if integration of fx is gx, then if I want to get gx to fx, then it is called differentiation. So gx by x, or in algebraic term, or in opposite to multiplication is division. If width into height is area, then area by width is height back. So division is opposite to multiplication. If fx dx is algebraic multiplication, then gx by x is fx back. Fx into x is algebraic multiplication, then gx by x is fx back. If fx dx is integral calculus, then dgx by dx is fx back. Okay, so this is called derivative. So if I know gx to fx, if I know any function gx for which I calculate the rate of collection, if it is collection, gx is collection. If I calculate rate of collection, that is derivative back to fx, then for fx from rate of collection to collection or integral is gx. So there are many ways we can calculate integral. One is through area, another is through going downwards. Like if I know polynomial integration, and something that is not polynomial, if I break it into polynomial downwards, lower side, and for lower side if I know the integration, then I can calculate the integration, or straightforward I calculate the area. Or if I have the answer gx, any function for which derivative is fx, then for fx integral is gx. There are many ways we can calculate the gx, that is integration of fx, area of fx. Now question arises is, what is integration of sin x? I don't know. I cannot break sin x into polynomial equation. I don't know area of sine wave, how to calculate. So integration of sin x, I don't know. Okay, can someone try differentiation of sine wave? So differentiation, that is rate of, from a collection, rate of collection if I want, then that is gx. If sin x is gx, then gx by x, or dgx by dx. dgx by dx means rate from collection. If I have x-axis, if I draw collection graph, then any moment rate of collection is different. We showed this. If collection is kx, then gx by x is k, constant. Then it's all right. I can do the division. But if collection is kx square, then division is kx square by x is kx. Again, it is coming into algebraic equation where rate of collection is dependent upon function of any particular x. So if I have x-axis and collection graph, if I draw to every moment, rate of collection is different. Gx by x is different. If that is the case, then we have to go different way. That is, at any moment x, if I want rate of collection through the function gx, that is the collection, then gx plus delta x minus gx divided by delta x, or that is at point x, rate of collection, or gx plus delta x minus gx minus delta x divided by 2 delta x. So if I do, this is called first principle. But we saw, if I try to do for the sin x, then it comes as cos x sin delta x be divided by delta x. Sin delta x divided by delta x is nothing but 1. This is something that is imagination, provided delta x tends to 0. If delta x tends to 0, means sin delta x also tends to 0. If delta x tends to 0, sin delta x also tends to 0. Delta x tends to 0. Since they are not 0, so 0 by 0 undefined case will not come. They should be similar. For God's sake, it should be similar, and sin delta x by delta x should be 1. If that case, then derivation of sin x is cos x. Okay, so finally we have come to a point where we have to prove that differentiation of sin x is cos x, but not through the first principle. That is the concept. Let's consider that I have polar coordinate. If polar coordinate is there, then this circle is centered at origin. So Mr. Center is the origin. Can you see? Mr. Center is the origin. If Mr. Center is the origin, then this is, if Mr. Center is the origin, then this is x-axis. This is y-axis. This is Cartesian form. This is radius A. This is radius A. And if radius is rotating centered at origin, then it is making theta angle. Now, if it is making theta angle, if it rotated theta, then this is the situation. This is the beginning point of the radius, and radius rotated theta. If radius rotated theta, then this is theta. If radius rotated theta, then this is theta. Then what is the sine theta value? I don't know. You can say what is sine theta value. But idea is, can we calculate d sine theta by d theta? D sine theta by d theta. If we make 1 unit change along theta, if this is theta at this moment, okay, this we have described it. If theta is 0, at this point, if I make 1 unit change in theta, how many unit of change is seen in sine theta value? That will be higher at this stage, because rate of change at this stage will be high. When it is reaching 90 degree, at that time, if you calculate that, suppose this is 85 degree, at this moment, if there is 1 degree increment, then how much increment happens in sine theta value at theta equal to 85 degree? It will be low in a sense. When it reaches 90 degree, then d sine theta by d theta, at that moment it is 0. When it is reaches 90 degree, then d sine theta by d, in graph you can see, if you draw sine theta graph, if this is origin, then it goes, and at pi by 2 it becomes maximum. So there d sine theta by d theta, if you increment at that moment, if you increment little bit also, you won't see any change in sine theta, because its curve is going plus and then it is coming minus. At one point it is stable. So when it starts at this moment, the rate of change is high, whereas the rate of change becomes slow. When it reaches peak, then rate of change is very low. I would say it becomes 0 at pi by 2. So at any theta, what is d sine theta by d theta? That is the question. So at any theta, if I make 1 degree increment, then how much increment I see in value of sine theta? D sine theta by d theta. So if theta is the angle, then this, if from this is the radius, okay, then full is circle. Can you see? If I see my finger here, then this is making a circle. This is making a circle. So this is polar coordinate. If this is polar coordinate, if this is theta angle, then this is y, vertical y. This is x, and this is hypotenuse, x square plus y square square root. Then sine theta is nothing but y by square root of x square plus y square. D sine theta by d theta equal to d of y by square root of x square plus y square by d theta. So this is what we have seen. Now let's increment it for d theta. D sine theta by d theta means if I increment d theta, then how much sine theta increase, and if I divide it by it, then it is same as if I increment 1, then how much it would increment. If I increment 2, then the numerator increment 10. 10 by 2 means if I increment 1, then it would increment 5. So 10 by 2 result is not 10, 5. 5. Division of 10 by 2 equal to 5 means if I increment 2, then numerator increments 10. If I divide it, then if I increment 1, then how much it would increment numerator? That is 5. 10 by 2 equal to 5 by 1, 5. So if that is the case, d sine theta by d theta, if I increment d theta, how much increment I see in sine theta? D sine theta by d theta equal to whatever comes, that value tells me that if I increment one unit, then how much the sine theta would increment. So d sine theta by d theta. So so if we are at theta, if we are at theta at this moment, if I increment d theta, then how much? Okay, consider if it is theta, then this is y and this is x. If I increment d theta, then it increments by delta theta. If it is theta and increment by delta theta, now net angle now is theta plus delta theta. If this is the y earlier, then if I increment delta theta, then it increments y. So earlier y was here. Now y plus, now it increment delta y. If I increment at theta, if I increment delta theta, earlier y was here. If I making it here, then slowly x is decreasing and y is increasing. So but it is x is decreasing. So if it is the case, consider consider this is y, and if I make a small change d theta, then this is new y. So that difference is delta y. So what we are trying to say is, now sine theta plus delta theta equal to y plus delta y divided by y plus delta y, okay, divided by x minus delta x if there is a delta x decrement. But this is not we want. This is tan theta. So sine theta plus delta theta equal to y plus delta y divided by square root of x minus delta x whole square plus y plus delta y whole square. Makes sense, right? Because x decremented, y incremented if I keep on rotating this. X is full hypotenuse. Hypotenuse, radius. Radius is unchanged. Can you see? Radius is unchanged. If I go like this, then x is 0 now and y became the radius. If angle is 0, then x is radius and y is 0. If I move it, x keep on decreasing where y keep on increasing. If that is the case, then sine theta plus delta theta equal to y plus delta y divided by square root of x minus delta x whole square plus y plus delta y whole square. So if that is the case, but the sine theta is nothing but perpendicular by hypotenuse. Hypotenuse is radius and radius length is unchanged. Can you see? It is not changing. This length is constant. So either you say when theta angle is just theta, then it is x square plus y square square root. That is the hypotenuse. When angle is theta plus delta theta, still the hypotenuse is same. That is old x square plus y square square. It is not changed. So we can say now that sine theta equal to y by hypotenuse, that is a, that is the radius. Sine theta plus delta theta equal to y plus delta y divided by a again. Makes sense? This is our proof. You will not get anywhere on internet or any of the book. Proving the differentiation of sin x is cos x, not by first principle. Let's move on. So now now we are calculating d sine theta by d theta. D sine theta by d theta, where sine theta equal to y by a constant a, that is the radius. So d sine theta by d theta equal to d y by a d by d theta. That is same as d y by a by dy into dy by d theta. If that is the case, then it becomes 1 by a. Y by a is constant. A I can keep outside, and differentiation of dy by dy is 1. So 1 by a into dy by d theta. So d sine theta by d theta is equal to 1 by a into dy by d theta. Can someone calculate this? What is dy by d theta. What is d sine theta by d theta? That is cos theta. I know it. If it is cos theta, then outside it is 1 by a. Then dy by d theta equal to x. If someone brings in dy by d theta equal to x, then he cracks it. Dy by d theta equal to x, and it's true. Dy by d theta equal to x, it's true. When angle is 0, at that moment hypotenuse is x, when it is full x. When at angle, if dy by d theta, if at if I increment theta, if angle is theta, at that moment if I increment 1 unit, how much y would increment? So here consider theta is 0. At this moment, if I increment 1 unit in angle, at that moment the increase in y is proportional to x, means when angle is 0, at that time dy by d theta will be very high. Sine curve, you can see, if you have x-axis and y-axis, and if you see sine curve, then immediately it will make a sharp rise, and slowly it will become stable. Then it will fall. Then when it is touching the x-axis, it will make sharp down. Then again it will become stable. Then here again it will be sharp up. So when it is touching x-axis, that is angle equal to 0, angle equal to pi, angle equal to 2 pi, at that moment the dy by d theta is very high. That is x. So when it is x, at this moment dy by d theta is high. Can you see that theta is growing but x is decreasing? When theta is growing, x is decreasing. When theta is 90 degree, there is no x. If dy by theta d theta equal to x, and when theta is equal to pi by 2, then dy by d theta, at that moment x is 0. This proves that at pi by 2 dy by d theta is 0. True. When angle is pi by 2, at that moment dy by d theta is true. So dy by d theta equal to x looks true. So d sine theta by d theta equal to 1 by a, that is the radius, that which is constant. Earlier it was y by square root of x square plus y square. D of y by square root of x square plus y square by dy into dy by d theta. That is d sine theta by d theta. Which one we have to take constant? Then if I take radius as constant, because radius, if I am rotating, radius is not changing anywhere. This proves that a square root of x square plus y square is constant. Then y by a, if I have said a square, then it is wrong. Y by a. 1 by a, I keep it outside, and then it is y, dy by dy, 1 by a, dy by dx. If dy by dx becomes x, then x by a, exactly, it becomes cos theta. So this I have to prove one way. This is one way of proving d sine theta by d theta equal to cos theta. Other way is, that is polar way. Polar way means radius is constant. Other way is, if I am at angle theta, and make a small increment as d theta, then let x be constant. If when angle is theta, at that time we have x. Then let be in this line one. Then go little up, and this is delta y when we increment delta theta. If we increment delta theta, it will go and touch the old line only. If this is theta, then I draw a line, vertical line. This is old line, one line. If I increment by delta theta, then it will go and touch the old line only. So x is constant, where there is a change in y, that is delta y. Sin theta equal to y by square root of x square plus y square. D sin theta by d theta is equal to d y by square root of x square plus y square by d theta, or dy by square root of x square plus y square square root by dy into dy by d theta. If I differentiate this considering x as constant, because x we are not changing, then it becomes, first I'll differentiate with the square root of x square plus y square. Then it becomes minus y 1 by 2, and then minus 2x minus 2y divided by then x square plus y square to the power 3 by 2. It will become minus y square divided by x square plus y square to the power 3 by 2 plus 1 by square root of x square plus y square square. If I settle it down, it will become minus y square plus x square plus y square. It will become x square divided by x square plus y square to the power 3 by 2 into dy by d theta. There are two things in polar coordinate. One is that you keep the hypotenuse constant, that is the radius constant, and move it. Another is you keep the x-axis constant, move in this direction. So if you move in this direction, that x being constant, so the hypotenuse will change. If it is angle theta, then this is the hypotenuse. But if d move this, preserving the old line, then the hypotenuse is changing where x is constant. If that is the case, then d sine theta by d theta. If that is the case, then d sine theta by d theta, d sine theta by d theta equal to minus equal to x square divided by x square plus y square to the power 3 by 2 into dy by d theta. If that is the case, then to bring it back to the cos theta, then someone has to prove dy by d theta equal to x square plus y square divided by y. If dy by d theta equal to x square plus y square divided by x, if that is the case, then whole will become x by square root of x square plus y square. That is nothing but cos theta. Let's proceed first of all, because that's what I have thought about. So let's now if this is where the hypotenuse is constant. This is the angle theta. If this is the angle theta, and this is y and this is x, this is x and this is y. If this is y and this is x and this is angle theta, then this point, okay, we will make now we increment it by d theta. This is theta, we increment it by d theta. So earlier position and new position. So earlier position, whatever, consider this is earlier position, this is new position. To make it clear, if this is earlier position, from this position we will draw, and this is new position. Can you see the arc? This is new position, this is earlier position. If this is point P, this is point O, center. This is point O, that is center. This is P. Then if I rotate delta theta, then this is Q. This is arc. If this is arc, okay, if I rotate like this, then at this point, this is O, this is P. If I rotate it d theta, this is Q. This is arc from P to Q. Okay, from Q, draw a horizontal line where up to a point where if I draw a vertical line, it will touch the P. If this is P, then draw a vertical line. Keep drawing it. And if this is Q, then draw a horizontal line. Keep drawing it. It will touch at a point. Consider it as R. Now, there is arc where one side is P, one side is Q. If this is arc, then from P, okay, P, I draw a vertical line, and from Q, I draw a horizontal line, and it touches at point Q. So I have a shape like vertical, this is horizontal. vertical and horizontal. The point they are meeting, this is Q. I'm sorry, R. This is R. Down the point, this is P, and this side it is, consider this side. This side, this is Q. This is R, and this is P. From P there is an arc. From P there is an arc that is touching the Q. P, Q, and R, R, P, Q, where this arc belongs to a center, that is O. So this height is delta y. This height is delta y. This length, what it decreased, this is delta x. Delta x is decremented. I don't worry. Whatever is delta y, this is delta y. Whereas this arc is how much? The angle for the arc is d theta. I believe it is all right. So if I have this at x-axis and this is angle theta, then this is angle theta. I make delta theta increment. If that is the case, earlier the point was P, then it became Q. Then there is a delta theta increment. For delta theta increment, there is an arc that came into the picture, P, Q. And then I draw a vertical line, then this is R. So it makes a shape like this. If this is R, then down is P, and this side it is Q, and there is an arc. What is the length of the arc? If the radius of the circle is A, then A d theta. Then the radius of the arc, the length of the arc is A d theta. So I believe I have the arc. So if this is the arc, then it forms like this. Can you see this? It forms like this. So this point is Q, this point is R, and this point is P. It forms like this. The length of this arc, because it through angle d theta, it is A. If A is the radius, A d theta. If this d theta is 2 pi, then this arc is 2 pi A. That is the circumference. So A 2 pi, exact length, A d theta. So this forms a kind of a triangle. It forms a kind of a triangle. It forms a kind of a triangle where one side is arc A d theta, one is delta x, that was x decremented, and one is delta y because of the delta theta increment. What we are trying to find? D sine theta by d theta equal to 1 by A, that is the radius, into dy by d theta, delta y by delta theta. So we are trying to find, if this is the case, then we are trying to find this is delta y. This is delta y by this angle is d theta, or this length is a d theta, but this is not a straight line. We will consider it as straight line. We will see it. Okay. So can we proceed from here to calculate the d sine theta by d theta? That we will proceed in this, and we will see that what it really brings in. This is not the first principle where we consider that d sine theta by d theta is nothing but cos theta sine d theta by d theta. Sine d theta by d theta, since d theta is tends to 0, so this is 1. There is no way you can prove it 1. So anyway, so we will proceed on it. It looks interesting. So we will see that how this, whatever triangle we formed, this triangle would lead to the differentiation of sine theta. So that we will see.